Okay, so today we are going to do two sessions, that is IO stream or file handling, and also we are going to discuss the Java applets. So those are two small topics. So straight away we start with input output streams in Java. Okay. So when it comes to input output streams, we can use input output streams to work with files, and also you can use it for standard input and output, that is console. If you are using console based application, and also you can use it for uh, socket programming as well. So that means if you want to write to a network connection, so you can use input output stream again, right? So therefore it's very versatile. That is, if you want to read a file or if you want to write to a file, local file, you can use it. If you want to write to the console or read from console, you can use it. Actually you have already used this using the system out println and system in classes, so therefore we are not going to cover that because we are already using this. And also if you want to write to a network connection, we call it socket. If you want to read from a network connection, again we can use the IO stream. Okay, so we are more interested about this one, write into the file and read it from the file. Okay, right. So before starting about these IO streams, we are going to first discuss how to handle files in Java program. So then we will be moving to the how to read and write to files, read from files and write to files separately. Okay, right. So let's first try to understand how we can handle files in Java program. So in order to do that, we have class called file. We have class called file, which is in the Java IO package. So again, it is not in the Java lang package, just like the collection framework, which was in Java util package. We always had to import Java util. Similarly, if you are working with files or input output streams, we have to import the Java IO package. Okay, Java IO package. Then only you can use it. Either you have to import specific classes, or when you are doing development, it's always easier to import everything using Java, import java.io.star. Then you can write your code. Okay, right. So when it comes to handling files, so the Java program represent a file using a file object, right? Using a file object. So in order to do that, you have to create a file object, right? File object. So when you are creating the file object, you must refer to either existing file. If not, you can create a file object and make it a file. That means you can use the file object to create a new file as well. Okay, so let's first try to understand how to refer to an existing file. Okay, so this is very practical topic. Anyway, programming is practical, so therefore I'm going to straight away go into coding. Okay, so I'm going to create a folder called my code in my D drive. Then I'm going to create a file called Java file. Let's say file demo.java. Okay, so I'm going to get class with main method. Right, so I'm going to create. So let's assume that we have a file, right? So let's assume we are going to work with that file using Java. So I'm going to get file called my file, or let's call it file.txt. File.txt. So let's add few text with something like hello world. So let's save it. Right now, I am going to refer to this file in my Java class. Okay, in my Java class. So first of all, because I am going to get a file object, I have to import Java IO package. I am going to import everything so that I don't have to import individually. Right, so let's create a file object. File, you can give it any name. Let's say f1 equal new file. It's very straightforward. Now this file class has several constructors, right? So the easiest one you can use it. You can straight away give you the file, the name of the file you want to refer to. So in my case, it is file.txt. Right? So let's call it something like my file.txt. Right? So I'm going to say my file.txt. Since it is in the same folder as my Java file, I don't have to specify the path. Right? It always look for the current folder when you are running the file. If you are not specifying the path, okay. So I am not specifying the path. Now I have a file object. Now I have file object. If my file is in different place, you have to specify the path, like D whatever the folder, etc. Okay. And so like this way, you can specify the path, right? Using the absolute path. Then there's overload. It's file class has overload constructor. So if you want to give, you can specify your file as the second parameter, file name as the second parameter, and path as the first parameter as well. If your file is in a different place from your current folder, or you can just give path together with the file in single constructor argument. So here also you are using single constructor argument. Here also single constructor argument. Here you have two constructor argument. In that case, first parameter must be your path. The second parameter must be your file. Okay, right. Now there are different methods available to work with the file. Right? Work with the file. For example, if you want to see what is the size of the file, you have a method called length. Right? If you want to create a file, say assume that the file is already not there with that name, you can create a file using create new file method. If you want to delete that file, you can delete the file using the delete method. Then you can check different aspects like whether the file is readable, file is writable, right? File is executable, and also this file object is used for both files and directory. Right? So the file also we create a file object. If you want to refer to a directory or folder, still you refer to a file object or you are creating a file object. So you can check whether what you are referring to is a file or directory. For that we have two methods: isDirectory method, which will return true or false, and also we have isFile method, which refer to again true or false. And again, if you want to double check your file name, you have getName method. And since file class is representing both file or folder, you can create new folder also for using mkdir method. And also you can check whether what is the last modified time, whether the file is hidden. So all those things can be checked. Okay, so let's use few of those things. Let's see the file name, right? File name and maybe the size of the file. Okay. So I'm just using the system out println. Uh, so my one object reference is f1. Let's say get name. Let's take the size also. For that we have method called length. Method called length. Right, so let's compile and run it. So I'm going to take command prompt. Move on to D. cd my code. I'm going to compile. So let's say Java C. I'm just using start.java. Okay. Okay, so there's a small mistake here. Not closing the brackets. Right, so let's recompile it. Right, so class has been created, file demo class. So let's run it. It says its file name is myfile.txt and the size is 12 bytes. So obviously it has to be 12 byte. I think I had only about 12 characters. I can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then we have the new line characters, for two new line characters, therefore it must be 12. Okay, right. So that is how you work with the file. You just create a file object. Of course, you have to import the Java IO package. Then there are various properties or behaviors of file object like get name, length, etc. So let's try out few more. I'm not going to try out everything. Right? I'm just trying out few things only. For example, if you want to get whether it's a file or directory, you can see call the isFile method. IsFile method. So it must return true in this case because it's anyway a file. Then I'm just trying out few things only. Everything is mentioned in your note. So let's say something like last modified. Actually, it must be a method. I just created the file. Okay, I just created the file. So let's compile and run it. So you can see that it says its file is true. So it is not giving you the date. What we are getting is an integer, right? For the last modified. So that is why I took it because it's a special method. So it will give you a long value, right? So in programming, we have something called standard time or Unix epoch time, right? So that is what you get is, so when you get this time, what you get is how many milliseconds have passed since 1917 January 1st. So that is the standard we programmers use. There are different standards also. Java use this Unix type format. So in programming, we consider that January 1st, 1917 as the starting time of the for the programming. Right. So therefore, if it is before that, it will be minus. So therefore, what you got is how many milliseconds has passed since January 1st, 1970. Okay. Of course, if you want to convert it to current date and time, there are some utilities you can use rather than you calculate the number of milliseconds using the milliseconds to the current date. Okay, so that is the last modified time. Okay, right. So likewise, there are so many methods, whether it's a read-only method, whether it's a writable method, etc. Okay, right. Now, if you want to delete the file, you can just call the delete method. Now already we have the file, so let's delete this file using the, now we have the file object, now we are going to delete it. Okay, so f1 dot delete. So some of these methods throw checked exceptions, IO exception. So let's see whether the delete is throwing IO exception. If it is throwing IO exception, which is checked exception, I will get a compile error. Okay, saying that we are not handling the exceptions, right? We did the exception handling in a previous session. So let's compile it again and run it. Okay, so no, okay, so no compile error means anyway delete method is not throwing any exceptions. Now let's see whether the file is there now. Now you can see file is no longer there, right? File is no longer there. That means the file has been deleted. Okay, right. So if you want to create a new file, for that also you have method, right? Now anyway the file is not there. Now I am going to comment this one. So assume that this my file text is not there. Now you can see the file is not there. If you want to create the file, you can your file object can use to create a file as well. So for that you have to say create new file. Then of course it will be empty file. Then you will get the name. Length is going to be 0 anyway, and it's again going to say it's true because it's a file that we are creating. Okay, create new file method. So create new file. Yeah. Now you can see that it is create new file method is throwing IO exception, right? So now we have to handle it. Right? Of course, the delete method is not throwing IO exception, but create new file is throwing IO exception, right? So let's handle it. Let's handle it. So I'm just anyway I'm going to put everything in try catch blocks because there are some methods that throws IO exception. There are some methods that does not throw IO exception. So anyway I'm going to put it into a try catch block entire thing so that I don't have to worry too much. Okay. Try. So I'm going to close the try here. I'm going to catch IO exception. Just going to say error. I'm not going to do anything fancy. Error occurred. Right. Right. So let's compile and run it. Okay, I haven't saved it. Yes. Right. Now let's see where the file is going to be created. Now you can see still no file is there. I just compiled it because the previous file was deleted using our Java program. Now let's execute it. Right. Now you can see the 0 byte. The file name is file my file and it's a file. Now let's see where the file has been created. Yes, file has been created again. Of course it's empty file because we haven't still written to that. So how to write to this file, how to read from these files, that is what we are going to discuss next. Okay, so the first you must be able to work with these files. Okay, work with these files. Now if you want to create a folder, that also you can do, or you can refer to a folder as well, right? So let's do something like that also. So let's create a file after that. So I'm going calling it F2 because even file and folder is just a file object for Java. Let's say my folder, and here we have to say create, not create file. So we have to use the make dir method, mkdir method. Okay, mkdir. Now let's run that. Anyway, the file is already created. It will recreate. So let's compile and run it again. because the folder is not created for some weird reason. Why is that? Okay, I am saying F1, it should have been F2 because F1 is a file already created. So let's call it F2. Now you can see my folder has been created, right? My folder has been created. Likewise, if you want, you can delete this folder now using the delete method. You can rename. So all those methods are there. So I don't want you to memorize these method names, right? I hope examiner is not going to check your memory. I hope he has better ideas to check your understanding rather than checking whether the breadth and width of your memory. Okay. So of course you will remember few of those methods naturally, but don't try to memorize. Forget about the exam. Try to understand the concepts. Try to build your skills so that you can anytime you can find out these methods by doing a Google search. As long as you know how to handle with files, the approach, you are going to start developing some software, serious software, right? Useful software. Okay, right. Now we are done with handling files and folders. Now we are going to move into the our next part, that is how to read those data from the files and how to write to files, because we are not interested about the shortcut programming or console programming, right? We are more interested about the file handling here. Okay, right. To work with files or read and write with files, we have another concept called related concept called input output streams, right? Input output streams. Now the file object is there to work with the file, like rename, delete, close, rename, delete, create, check the attributes, etc. But it is not for reading or writing to the file. For that we have separate class hierarchies. We call them the IO stream classes, right? So when you are reading, whether it's a file or console or socket, you can use input streams to read it to your program, and you can do whatever you want. Then when you want to write to a file from your program, you can go for output stream, right? So that output, using the output stream, you can write to a file, console or socket, right? Whatever, one of these three, right? Again, the IO streams are also in the Java IO package, right? So therefore, you have to import your Java IO package again. Uh, and the base classes are the input stream class and the output stream class. So those are the base classes when it comes to reading and writing, reading from and writing to a file. Right? So both the abstract classes. Therefore, there are some concrete classes we can use to do our tasks. Right? So the Java people wanted to make it extremely versatile. So therefore, not only just one just set of classes or two classes for input reading and writing, they came up with a hierarchy of classes with different features. So therefore, when what depending on your requirement, you have to pick and choose one of those classes. So sometimes you can combine those classes and do your tasks, right? So it's a very interesting area, but sometimes you will get confused because there are so many classes. We are not going to cover each and every class. We are going to cover only few, the most widely used classes. And again, we have a sort of a pair of classes, one class for input and compatible class for output, almost the same name, just input and output terms will be there. So therefore it's not that difficult to remember. So if you have something like character input stream, then you have character output stream. If you have buffered input stream, you have buffered output stream. So similarly, it comes as pairs. Okay. Right, now let's look at the basic class hierarchy, or the basic classes, that is the input stream and the output stream classes, right? So they have some methods like reading, read, write, skip, close. So those kind of methods are there in input streams and output streams, right? So the both have the close method. The input stream has the read method and skip method, whereas the output stream has the write method. Okay, so we will look at the more specific classes rather than the these abstract classes, because we can't create object out of these abstract classes. Okay, but those classes provide the basic functionality for the other specific classes to implement. Right. Then we have another type of filtering streams, etc. Right. Now let's briefly look at the not all the classes, some important classes in the input stream. Right. Input stream is abstract class. So under input stream we have file input stream, byte array input stream, filter input streams, pipe input stream, and object input stream. So out of these we are only going to discuss file input stream, byte array input stream, and the object input stream. Okay, so we are not going to cover other things, right? A little bit on buffered input stream as well and data input stream. Okay, so we are not going to cover other classes. So similarly, we have output streams as well, right? Same name, only thing is it's now not input, it is now output, right? So that is the only difference. So the file input stream, sorry, file output stream, file output stream, byte array output stream, uh, object output stream. Then here we have the data output stream, print streams, etc. Okay, so we are now going to cover few of those. So why we have set of classes are there are situations you want to read and write character by character. That means we are working with text files. For that we have what is known as this data input and data output streams, etc. Sometimes you want to read and write even binary data, something like maybe audio file, maybe the video file, or maybe some other executable file. For that we have general input and output streams. Then there are situations you want to work with objects. So that means you want to read an object, or you want to write an object to a especially if you want to send it to a network, some other network place or place in the network. For that we have the object input and object output stream. So don't worry, we are going to take one by one, and we are going to cover the most important ones that we are going to need. Okay, so let's start with the binary streams. So binary streams means we are going to read and write at binary level. So that means at bit level, right? For that we have the binary stream classes, two classes, that is the file output stream for output or writing, and file input stream for reading at bit level or binary level. Okay, so that is the most general implementation to read and write at binary level. Okay, but anyway we are not going to do it with audio video. I am going to demonstrate it using text file, but anyway this is applicable to any binary file. Okay, right. So these are some important methods in output, right? Or the file output stream class. We have the write method, right, with different overloaded write methods, and we have the close method to close it, right? Similarly, in file input stream we have the read methods and close method. Okay, right. So let's practically see how a file output stream can be used. Okay, so we are going to demonstrate that. So I am going to get another class. I'm just going to take a copy of this so that I don't have to write the main methods, etc. Let's call it file output stream demo. File output stream demo. So I'm just keeping the try catch block also, because anyway you see with IO stream also most of the time these methods throw IO exception. Okay, right. So what I'm going to do is I'm going to create a file output stream. Right. So now we don't have to work with file class, right? We can just directly work with the output stream and input stream, right? File output stream, file output stream. To that you have to give the constructor. To the constructor you have to give the file name, and then if there is no such file, it is going to create the file by the Java itself is going to create the file, right? So anyway, I have a file called my file. I'm going to just delete it so that let Java create the file. Okay. Okay, so that is how you create object, the file output stream object, right? File output stream object. Once you create that file output stream object, so let's just call it F. You can work with that, right? You can work with that to write to the file output stream that you have just created. Okay. For that you have a method called write, right? Write. Then you have to close it, and you have to close it. So let's write something and close it. F dot write. So I am just giving integer which is a valid ASCII value, so that it will be written in the ASCII value. Okay, so let's say something like valid ASCII value, like say 66. Then of course we have to close the. So there's nothing called opening, because when you create object, you are opening the file, right? So but you have to just close it. Otherwise you are just keeping the file open, so that other programs or manually you will not be able to change it. The OS is going to complain that file is opened by another program. So therefore it's always you have to close it. So this class name must be file output stream demo. Because the previous one also paid in the same class. So let's compile it again. So let's run it now. Anyway, now there is no text file here, right? No text file here. It's going to create the file now. File output stream demo class. Right? Now let's see whether it has been created. Yes, my file. There's a file called myfile.txt, and it has the character B. So character B is representation of the ASCII code 66, right? 66. So that is how you write to a file at binary level. So you have to create a file output stream object. Then you can just write it. Then you can just close it. Okay. Of course, IO exception you have to check, because this write method is and also close method throws IO exception. Right. So therefore you have to catch it, or you have to handle it. Right. So that is how you write at bit level or binary level. Now let's see how to read. Right. How to read. I'm just going to save this as file input stream demo. File input stream demo. So there I am going to create. Now once you understand it, is very easy, right? To file input object, because I am going to read it now. So I am giving the same name. So therefore I am going to read the file that I have just created using my other program. Then we can read it. So when we are reading, there are different methods again available, right? For example, if you want to read everything, uh, right? So you have method called get bytes, right? Get bytes. So it is going to read everything in your file, right? So now let's use that one, and it is going to give you an array of byte, right? Array of byte. Sorry, so that is writing actually. So let's move to the reading. So if you want to read something, you have method called read, right? Read. That is going to read the first byte in your file, right? First byte in your file, and then you can print it. Okay. So now let's read it. F dot read. Right. So it is going to be a byte. Let's say X. Now you can print it, so that we can see what is the value. System dot out dot print ln. So my X. So then of course you have to close it, right? You have to close it. Right. So let's compile it again. Okay, why is that? Yeah, not a byte, it is returning int, right? Not the read method is returning int, not a byte. Okay, you can always refer to the API. So it will say that it is returning int. Okay, so therefore let's recompile it. Now let's run it. So that must be Java. File input stream. That's correct. And now you can see it says 66. So the reason is what I have is in my file previously written is B. The ASCII code related to B is 66. So because we read it as a number. Now if you want to see the real ASCII code or the real character rather, you have to make it cast it to chart. So we have done the casting previously. So you have to cast it to chart, then it will say the real character which is in your file because it reads it as a binary. That is why it says 66 rather than B. Now let's compile it again and run it. Now it says B. Okay, because it's reading it as a set of binary values. Right. So that is how you work at binary level. And of course, if you want to write more than one character, now remember previously we wrote just one character. If you want to write set of characters, you have to take it into a byte array because you can't write a string straight away. Right? You can't write a string straight away. You have to take it into a byte array and you have to write the byte array because the write method has a overloaded version for byte array, but it doesn't have a version for string. Right? So let's do that also for our previous example. Right, so I'm taking back the file output demo again. Right, so rather than this, just one character I'm going to print set of characters. So string. So we can't call it, we don't call it string. Basically, we call it set of characters. For the file output stream, it's a set of characters. So byte array. Right. So you know that the string method has a method called getBytes, which gives you the byte array. So then we are going to use that method to write. So f dot write. So it is accepting byte arrays. It is accepting byte arrays, not only just byte values. So therefore it's going to work. Right. So let's compile it again. So what is our class name? File output stream demo. Anyway, we have the file, my file. It will be origin. Right? It will be origin. Currently, my file has character B. Now let's see. Now you can see it has been written. So that is how you write to a how you write a string or set of characters. Make sure you convert it to byte array, right? Using the getByteArray method of your string class. Then you can write it. So because write method is overloaded, it accepts not only byte, it accepts array of bytes as well. Of course, it has some other overloaded methods as well. So you can always refer to when you're developing softwares. If it is Java program, you can always refer to Java API. It's just fingertips at your fingertips, right? So just do a Google search, get the file Java API. It will say what are the constructors available. Now you can see for the write method, as you can see so many write methods are there. It is accepting int, and you can see that it is throwing IO exception. It accepts byte array of bytes, right? And it accepts so many other things like byte and some offset length, etc. If you want to extract portion of your array and save it, right? You don't have to memorize these things because you can just get it. The only thing is you must aware that these facilities are there. Okay, right. Now earlier we just read just one character or one byte. Now if you want to read entire file or say part of your file, for that also we have some facilities, right? For that, if you want to do that, what you are supposed to do is, now here we just read one byte, okay, one byte. Now if you want to say read everything for the entire file, you can go for something like this, right? I will explain it after coding it. Now I'm going back to the our file in output, sorry, file input one, right? File input demo. uh, so earlier we just read one byte, right? One byte and printed it. Now we are going to read the entire file byte by byte, right? Byte by byte. So what happens is when you're again we are going to use the read method, right? Read method, it's going to read one byte. But when you are at the end of the file, your read method is going to return -1. So that is how you know when you are reading it byte by byte. That is how you know whether you have come to the end of the file, because we want to stop at the end of the file. So what we are doing is, as long as your read method, so let's make it f dot read, is not returning -1, you are going to keep doing this and you are going to get it to a variable. And since it's a byte value, and we know that our file is a text file, characters we are having, we are just casting it to char each byte. So then we are going to get the characters by character, and we are going to print character by character. Okay, so then we are just closing it. Okay, so again we are using the read method. The idea is the read method is always going to call the next character, next character, next character. So the read method do two things. First, it reads the current. So for that, actually you have to understand there's some concept called file pointer. So when you are reading a file, your file pointer is at the beginning. Okay, file pointer is at the beginning. So therefore, it is going, when you call the read method, it is going to read the first character or the first byte. Not only it read the first byte, it shift your file pointer to the next byte, right? Next byte. So therefore when you read again, actually you are read in the second byte. When you call the read method again, you are calling the third byte. So likewise read method is not only read in the first byte, it is shifting the pointer to the next byte as well. So therefore when you are at the end, right, so when you create the last character or last byte, now there is no more byte to read. Therefore, your file pointer is now referring to something called -1. Or there, if there is no nothing to read, your read method is going to return -1. So therefore, we can use it to check whether we have come to the end of the file. So as long as it is not -1, we are going to keep reading and getting it to a variable, and it's a byte variable, and we are going to convert it to char because we know that our file is a text file. Okay, so let's read it again. So now remember last time we wrote set of characters to our file called my file using our other class. Now we are going to read this particular file, not just one character, entire file. Okay, now let's see. Right. Right. So the file pointer is going to use, or the file pointer is going to keep moving until it comes to the end. When it comes to the end, it is going to be -1. So therefore, we can just check whether as long as it is not -1, we can just keep moving in a loop. Okay. Right. So now let's run it and see. So this is supposed to read the entire thing and print, because we are reading byte by byte and we are printing then and there. Okay, so let's compile and run it again. Right, so it has read the entire file because we have been reading it as long as it is not -1, right? As long as it is not -1. Okay, so that is how you read the entire file. That is how you read the entire file. Again, we are not using different method, just the read method, but you can loop it until -1 because -1 denote the end of the file. Okay, right. So that is how you work with file at byte level, right? Reading and writing byte by byte. So you can use it even for read any binary file as well, like audio or video. But here just we demonstrated it for characters or text file, right? So then, if you are pretty sure that we are working with text only, so there's a much more convenient stream. We call it character stream, right? Character stream. So the character stream is specifically there to work with text files, right? So of course we were working with text files, but the interface for the classes that we use is more general class, byte oriented class. But now we are going to work with the character oriented streams for read and write. Okay. For that we have two classes. So the names are little bit different here. So we have the file writer to write and file reader to read. So usually we have something called stream in most of the class names, but here you don't have the stream in your class names. They are just file writer and file reader, right? File writer and file reader. So that facilitate the file writer facilitate you to write character by character. The file reader facilitate to read character by character. Okay, so let's do a file writer demo. So I am going to just save this file output stream, save as file writer demo. File writer demo. So let's call it file writer demo. So there I'm going to create a file write object because I am going to write character by character. Character by character. Again, I am reusing the same name, myfile.text. So let's delete everything in the file now. Okay. Right. So I created a file write object. Now let's see how to use the file writer class to write something. It's very easy now. You don't have to convert it to byte array or whatever. Straight away you have a method called write. It accepts strings, right? It accepts strings. So therefore you don't have to do this here, which we have to do when it comes to byte streams. Now you can straight away write your string, right? Straight away write your string. So just to double check whether the new thing is here, I just write 1, 2, 3 here because I am reusing the same name, same file. Now let's compile and see. So I'm going to run file writer demo. Right. Now let's see whether it has been written. Yes, you can see it has been written. So now you can see it's much more convenient, right? Much more convenient because it has it is accepting a string as a argument. Now again, if you want to write multiple lines, uh, enter is not going to work. If you write something like this, it's not going to work. You have to use a new line character, right? You have to use a new line character. So let's do like that. Let's say /n, then let's say something like this. So it must go into the next line. So let's compile it and run it. Now let's see the file again. Okay, so it must be other way, \. Okay. Now you can see it has moved to the next line. Okay, next line. So why we have space here? So this is extra space. Why? Let's see why. Okay, because we had this space. Okay, so we have to remove this space. Right now it should have been better because I just wonder why we are getting space here. Okay, now let's compile and run it again. Right, now it's fine. Okay. Right. So likewise, you can use these non-printable characters like backspace, tab, new line, etc. as well. Right. So that is how to write to a file at text level using the file writer. So now you can see it's much more convenient because this is the class that is supposed to be used when you work with text. Now let's see how to read. How to read at text level. For that we have the file reader. So I'm going to just copy paste file input stream because there's a pattern, so therefore I can reuse a lot of code. So let's call it file reader demo. So now I'm going to create a file reader object. Same file. Now I don't have to do this kind of a complicated things. I can read in a much more convenient way. Right? Now let's see how to read. Okay, so the reading is pretty much the same. Sorry, the reading is pretty much the same. Only the writer we have the convenient. Again, we have to read line by character by character. So that line is going to be the same. Okay, right. So that is going to be the same. So we are going to read by character. So the convenient is when you are writing. Okay, convenient is when you are writing. Now let's run it and see. Now let's call it file reader demo. By the way, let's double check whether we have a different or more convenient approach than this one. So I have given you the reference as well. So I'm referring to few websites which are really good ones. So for this one, Java Point is really good website. Okay. Now let's see. File read has an even convenient part. File reader. No, right? So same method we have used. Okay, same method. So let's use it. So let's compile and run it. So now class is file reader demo. So it must read the same thing, but now we have two lines as well. Right, so it has read the entire line because new line character also, or the new line character also you can read. Right, you can read. So there's a new line character here. You can read it as well. Okay, so that is how you work with character level. How you work with files. So that is the file writer and the file reader. Right? File writer and the file reader. So that is character streams. Okay. Right. Now we are moving to a different concept. What is known as buffered streams. So buffered streams are not a different. It's not to work with different type of files. That is to improve the performance of your file handling. So buffered stream has a completely different objective. Buffered streams are to improve the performance of your file handling, right? So when you are reading and writing, operating system does not. Operating system is busy with so many other tasks. Therefore, it is not going to straight away pay attention to your writing or reading, especially writing, right? So it's going to keep it in a queue and do those things in a when it has time to work with the your disk, okay, disk. But if you use a buffered stream, it is going to make a little bit faster to work with the files. So therefore, if you want performance, sometimes it's preferred to go for buffered streams rather than the normal streams. So buffered streams can be used with binary streams as well as character streams. Again, it's very easy to remember. For the binary streams, like the file output stream, we have buffered output stream. Right? For the file input stream, there's a small mistake here. File input stream, we have the buffered input stream. And again, if you are using writer, that means at character level, for the file writer, we have buffered writer. For the file reader, we have the buffered reader, right? So you can see that each class has a corresponding buffered class, right? It's very easy to remember once you understand the pattern, okay? So it is not good. We are not going to do it in a different way. We are just going. It is going to just improve your performance of your input and output only, okay, right? So therefore let's demonstrate it for just one of those things. So let's create a buffered output stream, right? Buffered output stream. I am going to use the file output stream class, file output stream class. Then I am going to call it buffered file output stream demo. So doing these things practically is the real effective way, right? So right now we have the file output stream, the normal file output stream class, right? Right in this. Now I'm going to make it a little bit more performance wise improved. Therefore, what I'm going to do is something like this, right? Of course, I am going to create the file output stream. Afterwards, I am going to create a buffered file output stream as well, or buffered output stream. Right. So after this line, I am going to create a buffered output stream. For that, right, for that, I have to send the previous file output stream. Right, previous file output stream. That means in my case, that is F. So I am sending the F. That means your buffered output stream constructor expect a file output stream. So it is going to make it a buffered version of it. Right? It is going to make it a buffered version of it. Then rather than working with this file output stream, we are going to work with the buffered output stream. So let's call it BF, buffered file. Right. So now we are not going to write it to this file output stream, rather we are going to write it to this buffered output stream. Of course, this buffered output stream is related to the file output stream, okay, file output stream, okay. So I hope you got it. Then we are going to write it to the buffer, and there's another additional method called flush that you can use to immediately flush it to the hard disk or the disk drive, okay. So now let's use it. Now it is not F, it is BF. Then additionally you have a method called flush as well. So other than that, all the other things are the same. So that means you are writing this particular set of bytes, array of bytes, then you are flushing it. Then of course you have to close both buffered output stream and the file output stream. Right? Buffered output stream and the file output stream. No, I think it's okay to close only the buffered output stream. Okay, so let's close the buffered I think we better close both. So let's close both. So I'm going to close the buffered output as well as the file output stream. Just I will check whether only one is required. For the time being, let's close both. So that's it. So only difference is now we have sort of wrapper for file output stream called buffered output stream, and we are working with the buffered output stream rather than the file output stream, because indirectly only it is working with the file output stream. So the output is going to be the same again, right? So just to check whether we are getting something else, they will see, we'll see something else also. Let's say 3, 2, 1. So let's compile and run it. Okay, so the class name must be different. Buffered file out stream. Okay, flush. Why not flush? Okay, for when you're flushing, you don't have the you don't have to do that. It's just a flushing entire thing. Okay, so it is not just that byte of things or whatever available. So there is it's a no argument constructor, no argument method. Okay, so it was a mistake. Now let's run it. Right, so I just added 3 to 1 at the end just to check whether our new text is there in the file. Okay, because we are using the same file. Yes, it has been written. So the only thing is it's going to be a little bit more faster to access the disk. Okay, because we are using the buffered output version rather than the normal output stream. Okay, so that is just to improve the performance, So similarly, for input also, when rather than using the file input stream, if you want, you can use the buffered input stream. That means you have to send your file input stream to the buffered output stream, then you use that buffered input stream to do the rest of the stuff. Okay, right. So let's change that also. That means I am going to create from file input stream. Sorry, from file input stream. I'm going to copy paste it. Buffered file input stream. Buffered file input stream. So I'm going to create a after this I'm going to create a buffered version. With that I'm sending this buffered input stream object. So let's call it BF, buffered file. Right, now when you are reading, you can read from the buffered input stream, which is connected to your file input stream, BF. Okay, and then you can close BF buffered one as well as the normal one. Right, now let's read it again. Now this time I'm going to run this. So same thing has been read. Okay, right. So that is just to improve the performance. So given the file input stream, you can create the buffered input stream. Then of course you have to use your buffered input stream. Similarly, given the file output stream, you can create the buffered output stream. Right. So same thing can be applicable to your character streams as well. okay, character streams as well. In that case, giving your file writer, you have to create a buffered writer, right? When you are writing, when you are reading, given your file reader, you have to create a buffered reader, then you can work with a buffered reader. So I'm not going to demonstrate those things. Those things you can try out at home, right? Right, now we are moving to the final part of the file input handling, input output handling. So now we have discussed how to read and write at byte level or binary level, how to read and write at character level or character by character. Now we are going to discuss a very interesting concept called writing your objects to the file and reading your objects from the file. Right? So that is object. You can write your objects, right, to the files and later read it. Not actually that is done most of the time when you are doing network programming like shortcut programming. You can send your objects that you have created in your current JVM. You can save it to a socket or the network connection and send it to another computer in the network. In that JVM, you can recreate that object and you can use it. So that is heavily used in middleware architecture or sort of a distributed programming. Right. So that you have that particular subject in your final year, the middleware architecture and the distributed computing. There you will be using these concepts called serialization and deserialization. Right. So still it may not give you a lot of sense right now, but these concepts are going to be really useful when you are in your next levels or the level 3 especially doing distributed computing etc. Where in real world software what happens is not everything is going to be run on one particular machine. You are going to work with so many other systems. Like if for example say you are having a web-based shopping cart system, you are not going to do the payment transaction. Payment transaction is going to be done by a bank. So for that you have to communicate with your bank's web service, right? Web service in that kind of situations, sometimes we can use these serialization techniques, right? So if you want to remotely communicate with other systems at object level, right? Object, not only object level, we have now some other levels as well, like web services, etc. But this is another level of interactions. Okay, right. So now let's see how to work with that. So the technical technologies like Java Persistence API, Hibernate, Enterprise Java Beans, Remote Method Invocations, Java messaging services. So you are going to touch each and every technology later in your final especially in your final year. So there you are going to use these things. So therefore, it's very important to understand these concepts here itself so that you are not in trouble when you go to the final year. Otherwise, what will happen is you are going to stuck there because you don't know the concepts behind those technologies. Okay, right. So now let's see how to write your object to a file, because we are not going to do shortcut programming right here because you haven't done any networking or network related subject yet. So therefore we are just going to write to a file, right? And also let's try to read that file, but we are going to write an object. We are going to write an object and we are going to read the object. Okay, so that's a very interesting topic. Right, for that object level reading and writing, we have a class called object output stream for output or writing, object input stream for reading. Right, so those are the two things here we are going to use. Okay, right. So and we are going to write objects. Right, no, we are not going to write binary level. We are not going to write at character by character. If say we have account object, we are going to save our account object to a file. Say I have a dog object, I am going to save my dog object. Say you have a payment object or order object, you are going to save your order object or payment object, right? So then the other party is going to read that object and create that object in the JVM, right? JVM, just like the previous object you had in your JVM, or it can be even different JVM if you are sending it to a other JVM through the network, right? So that is the idea behind that, right? So if you are going to serialize an object, you have prerequisite, that is the class that you are going to serialize the object must have implemented a marker interface called serializable, right? It's a marker interface. That interface doesn't have any method that you want to you have to implement. No, it's just a marker. You just have to say this class or the object of this class is going to be serialized. Then only JVM is going to handle that. Okay. So therefore, you have to make sure that your objects are your classes that you are going to serialize are all implemented in the interface called serializable, which is also in the Java IO package. Okay. So let's create a class first. Okay, let's create a class first. So let's create a class called student. Okay, for this demonstration. So you can create whatever the class you want, account or whatever. Student.java. Just have say class student. You can have any number of your attributes and behaviors here. So we are going to just copy paste a few attributes and one maybe just a constructor. Right, so we have two attributes, so instance variables and a constructor. Right, if you want you can have methods as well. I just introduced two instance variable and a constructor. So this is my constructor, overloaded constructor with two parameters. First one integer, second one is a string. Okay, right. So if you are going to serialize student object, now as I told you, you must implement interface called serializable, which is in the Java IO package. Therefore, I am going to import it. I'm just going to say star for the convenience, so it will implement import the serializable interface. Now we have to say implements serializable right. So usually when you implement a interface, you have to implement each and every method in that interface, but in serializable interface is a marker interface, right? So therefore you don't have to implement anything because that interface has no method, right? No method, just to let your JVM know that these student objects are may not be, may be serialized and deserialized. That's it. Okay, so therefore you don't have to implement any. If you want to do Google search, you can just serializable. Okay, see Java IO. Let's go to the Java API serializable interface. Now we see that there is no method. If there are method, it has to show you, right? No method, it's just a marker interface, right? A marker interface. That is why there are no methods here, right? If you go to when you go to other classes, we found some methods here. It's just a marker interface. If you want, you can just read it. Right. You can see the classes that do not implement this interface will not have any of their state serialized or deserialized. Right. So serializability of a class enables the class implementing the Java IO serializable interface. Classes that do not implement this interface will not have any of their states serialized or deserialized. So that means if you want to make your state serialized or deserialized, you must implement the serializable interface. So I want this to be serialized, therefore I am implementing the serializable interface. Okay, right. So if you have any questions, you can ask. Right. I hope you can still hear me. Yes. Right. Now let's compile this one. So I'm going to just compile everything. Right. So that student class is now compiled. Now let's create a student object and serialize it. Right. Serialize it. For that I'm going to create a class called serialization demo. Right. Serialization demo. Right, I'm going to reuse my file output stream class because a lot of code I'm going to reuse, and I'm going to say serialization session demo. Serialization. So there I'm going to use the file output stream again, right? File output stream, but this I'm going to create a, now I'm using the file output stream, right? So let's delete this my file, text files, everything. Now I'm going to use the same file name called my file. Now what I'm going to do is I'm going to create a using the file output stream, I am going to create a file output object output stream, because that is the class we are going to use for serialization. Now I am going to create an object output stream, just like a buffer, something like a buffer, but this is for different purpose. For that you have to give the your file output stream as the parameter. In that case that is f, and I am getting a object output stream now. Object output stream to work with. Okay, to work with. Right, now I'm going to create an object of our student class. Let's say student. Let's say s equal new student. Since I had my overloaded constructor, I'm going to use it. First one I'm expecting an integer, second one I'm expecting a string. Right, so let's say this is 56, and let's say Ravi Fernando. Right. Now I must be able to, now I am going to serialize this object. Now this is an object, right? I just create an object. I am going to serialize this to file. For that I am going to use the object output stream and serialize. Okay, so let's see what is the method. We have a method called write object, right? Write object, and then we can just flush and close. So this my object file output object stream is called out reference variable. For there we have a method called write object. For that I am going to send my object. In my case it is s. Then you can write. Now it is out, right? Our object output stream is out. Out.write. If you want you can flush it as well. Flush facility is there here also. Let's flush it also. Out.flush. And you can close your out, and if you can close your f as well, f.close, that is your file output stream. So I'm right closing both the output stream and the object output stream. Okay, right, so that's it. Now let's compile and run it. So I am creating a student object. I am serializing, or I am saving that object to the file. Okay, file called my file. Let's compile and run it. Okay, close. We have small issue, semicolon missing. Okay, so I didn't change the class name as usual. Serialization demo. Okay, so out.write, so that is wrong. We have delete this. This is coming from the previous code. Now let's run it. right? So no errors. Now the object, my student object has been written to this my file. Sorry, not my file. Why it hasn't been written? For weird reason it hasn't been written. So let's run it again. Serialization demo. Okay, I have been executing different class. So let's execute the serialization demo. Okay, sorry. Right, now only serialization demo has been executed. Previously I was executing different class. Now let's look at the my file. Now you can see it has some characters, right? Some text, or not text actually. This is a binary data. It has no meaning for us. But if at least you can see that something like Ravi Fernando and things like that are there. But this is actually by bit level or the binary data which has been written. This is not intended to be read by the humans. This is going to be read by the our deserialization class and restore the object back in the JVM, right? So therefore forget about this. This is not intended to be read by the humans. I just open it for my curiosity and now it has been serialized. It has been serialized. Now let's see how to deserialize. Usually this is going to be happen later or in a different JVM. So this is actually not going to be a file. This is going to be a shortcut programming and it is going to be sent to a different computer. There it is going to deserialize and work with the student object from there. Okay, now let's do that. So what I'm going to do is deserialization is pretty much going to be same related to the file output stream, right? Sorry, file input stream, because we are going to read it. Therefore I'm going to use the file input stream demo to do this. Okay, so I'm going to sorry, take a copy of file input stream and I'm going to say deserialization demo. And deserialization demo. Deserialization demo. Right. So from the file input stream, and now I am going to create a file object input stream. Right. Object input stream, and I am going to use the read method there. Just like the write object, we have the read object method. Right. So from the file input stream, I am going to create a file input object input stream, and of course this myfile.text file has the serialized student object. I'm going to deserialize. How to deserialize? You are going to use the in your file input stream class object. You have a method called read object, which will give you object. So you, since you know that what you have is a student object, you can cast it to student, right? So you can cast it to student because you know that your my file is having a student object, therefore you can cast it safely. Then we are going to now all of a sudden now you have student object which you created previously. Now it has all the attributes also, the instance variable initialized to whatever you have written. Now earlier it was 56 and Ravi Fernando. Now let's print and see whether it's 56 and Ravi Fernando from our student object. Now we are back to the object reader, our object level. Okay, so let's close then the object input stream and the file input stream. File input stream. Now let's see whether we are getting this output from the deserialization demo class. Okay, so you can see here you have there's another checked exception you have to catch, that is called class not found exception. So we have to catch that as well. Right? We have to catch that as well. We know that if there are multiple exceptions, there are different ways you can catch. We discussed that in exception handling. So I am going to use this particular approach using the pipe character. Right? Remember we discussed that about few days back, last week I think. Let's call it FE. Or you can just catch the general exception class, because everything is exception. I'm just using the other approach. Okay. Okay, so I have syntax error, so we have to use it only once. Okay. Right, now I am done because I have checked both the exceptions. Right. So once you know those things, once you learn it properly, programming is not going to be any stressful thing, right? Because if you don't know, right, if you just try to pass your exams, you are never going to be a software developer. You are not going to develop anything useful, right? So you are just going to get a certificate and you are going to die with your certificate, right? Just a paper. Okay. Right. So let's run it and see whether we can get the object back. Right now you can see 56 Ravi Fernando. So that means we have reinitialized, reinstantiated the object from the file, and again we have the object back. Right. So this is usually done in one machine serialization, sent to the other machine through the network. There again you have the object. Again you have the object. Then it can do the processing. Right. So we have in middleware we have something called object-oriented middleware. Right. In object-oriented middleware we use the serialization deserialization concept. Okay, so there you will find this really useful thing. And so I will just show you. So in your semester 6 you have middleware architecture subject, and there you have something called object oriented middleware, right? Object oriented middleware, there you will encounter these concepts. So if you haven't understood here, you are not going to understand object oriented middleware there. Okay, so there are so many things like COBA. Then we have Java version also. That is also COBA. Right. So there's something called Java remote method invocation, RMI. That is what I mentioned in our note also. It is used in RMI. You can see remote method invocation. Right. So there we use this concept called serialization. So and deserialization. You can see it has to be serialized and sent. You can see it, you have to implement the serializable interface. Then you can send it to the other machine. And there you are going to deserialize. Actually, we are going to do that kind of demonstration using two machines when you are in the semester 6, right? So we are going to use one machine and another machine, and we are going to send it to the other machine and through the network, and going to deserialize back to the. It can be even this one machine is Windows machine, other machine is a Linux machine. That is also fine as long as they have the JVM. Okay, right. So okay, now we are done with input output handling. We did a demonstration on serialization and deserialization as well. Okay, so then we have a very general class. So that is our final subtopic called uh, print writer class. So print writer class is given to you especially to work with consoles like Java out, so system.out, system.in, to work with system.out, system.in a convenient manner. They have come up with another class called print writer, which is also part of the input output streams. Okay, uh, so So let's briefly look at that one also. Let's call it so print writer demo. Okay, print writer demo. So that is our last demonstration. So after the class, you can just go through your BIT slides as well and see whether everything has been covered. And can you understand everything now? Okay, so let's. Right, so it's just a convenient class to work with reading and writing again. Especially it is used for other streams like console. Okay, but anyway, just copy paste the code, then I will just demonstrate it. So I'm just catching the exception class. Okay, let's catch the IO exception only here. I don't need anything else. Right. So we are creating a print writer object, two print write objects now. So what is known as writer 1 and writer 2, right? So the first print write object I am sending system out as the input. So we know that system out is the console, right? For the second print write object, I am sending a file object. So let's call it test.txt that we already have, right? Or let's call it myfile.txt. So let's delete the serializable object now. Save, right, myfile.txt. Right, now this is I am creating a print write object using system out. I am creating a print write object using file just to demonstrate, right? Then so the write object has a method called write. Then we can flush and close. Here also we are doing the same thing, but here we are doing it for the system out. That means it's going to be write to the console. Here it is going to be write to the same thing. Here it's going to be write to the file. Of course, you don't have to do this kind of thing. If you just write it like system out.println, it's going to work. But not only system out, we have some other things as well, system error, etc. If you are going to use those things, you can use this approach. Very handy. And of course, you can do the same thing with the reading as well. This is just to demonstrate the writing to the console and to the file simultaneously. Of course, if you want to just write to the console only, you can go for this. Of course, if you want to write the file, there are so many other ways as well, but just to demonstrate that, you can use the print write as well. Okay, print write as well. Now let's compile it and run it. Okay, right. Why it says print writer can't be found? Okay, writer 1 cannot find symbol. Okay, so it must be print writer, right? So I just cut this in different ways. Right, print write object. So let's compile. Let's run it. Print writer demo. Right. Now you can see it has been written to the console, because first I am writing it to the system out. I am creating the print writer using system out. Second time I am creating a print writer using the this particular file object. Now it has been written to the myfile.txt as well. Now let's see whether it has been written to myfile.txt. Right, it has been written to the myfile.txt as well. So you can see same print writer object class. I am creating two objects, one connected to the system out, the other one is connected to the file. So likewise you can work with the print writer as well. Okay, print writer as well. So that is just a brief overview of that. Of course you know how to read from system in, etc. We did those things at the very beginning of the course. Okay, right. So for that we have the system in, then other than system out there's something called system error, etc. Okay, right. So we are done with file handling, right? So now we are moving to the another topic, actually completely different topic, because we have enough time. I just picked two topics uh, today, that is applets. Right, applet is a very small topic, it won't take more than half an hour. Okay, so now let's move on to the applets as well. Okay, so I'm going to create a folder called applet here, applet demo. So I'm moving to that folder. Right, so let's start with applets now. Right, so applet is a Java program which can be run on your browser. So that is called applet. Right, that is called applet. Actually now applets are not supported by web browsers. Very hardly web browsers support applet. Actually almost all the web browsers have discontinued supporting applets. Okay, supporting applets, because applet has so many security loopholes and security concerns. So therefore all the browsers including the Chrome, Firefox, they have discontinued support for the applets. But if you want to run applets, you have to download special version of those browsers. Special version of those browsers. For example, if it is Firefox, you have to download. Uh, there's a special version, you can download it from. So I can't remember the exact name. You have to do a Google search and download that particular version of the Firefox. It only that only going to support applets. So that means applet is no longer used by general web development. General web development, because users don't have, the web users don't have that particular version. What they have is just the normal Firefox version or the normal Chrome version. Definitely those normal versions are not supporting applets. Okay, so that is why applets is now a little bit outdated concept, but still there are some proprietary applications still using applets, right, especially inside organizations. So that is why they have just kept it topic, because it's always handy to know those technologies, but don't expect applets to be there for a long time. So maybe in few years back, after few years, the applet is going to be sort of a history. Okay, so so keeping that in your mind as well. Okay, so therefore I'm also not going to use the browser to test my code, because browsers are no longer supporting applets. I am going to use a built-in Java program called Applet Viewer to test the applet. because I don't have actually I wasn't worried about the downloading that special version because that is very rarely we do now. Okay, so therefore I'm going to explain the theory part and I'm going to use the Applet Viewer to demonstrate few of those concepts. Okay, right. So what is mean by Applet? Applet is a Java program which is run in your browser, right? Which is run in your browser. Of course, if it is what happens is you write your Java applet code, which is just a Java code. Then you have your HTML or your web page or HTML or PHP or whatever. Then you write your Java file, Java code. You compile it to create the class file. Right, create the class file. Then you embed or connect your class file to your PHP or HTML or web page. Right. When someone access your web page, so the browser client is going to get the web page, and since you are referring to this class file, it is going to get the class file as well. Now the client get the web page and the class file, then this class file is going to be executed in the client browser, and of course the client machine must have JVM installed, not the JDK. Java runtime is good enough, so JVM or JRE must be installed in the client. As long as the client has the JVM or JRE, this class file is going to be executed in the client machine. Okay, so that is how the applets work, right? Applets work. Of course, this applet have a lot of access to Java classes, which includes file handling as well. So therefore, it's a very serious security concern to download a Java applet to your machine, because that applet might even access your hard disk, right? Access hard disk and do some nasty things. But of course, applet has a lot of restrictions, but still there is a possibility of security loopholes. That is why almost all browsers have discontinued support for applet from their standard browsers, because it help or it provide facility to hackers and other people to access your computers, because most of the time you are not aware that applet has been downloaded and running on your computer. So therefore it's a security issue. That is why almost all the browsers have discontinued support for the applet. But the reality is, when the Java was first developed in early 1980s, their main application was applet. So Java was developed to be run on the run as a web application, right? But now that concept has been thrown away, kick out of the web development because of the serious security concerns. But now Java is used for different other purposes like desktop development, server-side development, etc. Applet is no longer supported by almost all the browsers. Okay, right. Anyway, so let's look at the concept behind applets. Okay, right. So as I told you, so you have your web page. There's a tag called applet tag in HTML, which you can use to embed your applet, right? So that is your class or the bytecode. Then it will be loaded together with your web page, and as long as your client has a JVM, it can be executed there. It can be executed there. Okay. Right. So if you want to create applet, you have two options, right? That is, either you can extend applet class or you can extend the JApplet class, right? The applet class or the JApplet class. So JApplet class is the more versatile class where you get access to the user interface development technologies like Swing. If you extend it from applet, you are going to get only support of the Java AWT. But if you need support for Swing application support, you have to go for JApplet. Anyway, the Swing and AWT is the one of the topic that we are going to cover after thread programming. That is the final topic that we are going to cover. There you will better understand what is meant by AWT and Swing. Okay, so that is two variations of UI development, but most of the time we go for JApplets. Okay, right. Now let's see how to work with applet. Uh, so let's first create a HTML page. Okay, let's first create our applet class. Let's call it my applet. So while we are developing the code, writing the code, we will understand the concepts. Okay. Java. Okay. So what I am going to create is just a class my applet. I am going to extend JApplet. JApplet. So JApplet is in a package called Java Applet package, right? Java Applet package. Therefore, I am going to import Java Applet, everything in the Java Applet package, so that I don't have to implement import separately. Let's start. Okay. So I just use Java JApplet rather than the applet. Of course, I am not going to use any UI development. Therefore, I can even go for applet as well. Let's go for applet for the time being. Extends. Okay. So that is how you create applet. You have to create your class extending from applet to JApplet depending on the support of UI you want. Okay. Right. So now remember, we are not going to run this applet by ourselves as a user interface designed application or a console application. It is going to be run by your web browser. So therefore, there is no concept called main method here, and no concept called main method here. Rather, we have a method called paint, right? Method called paint. Now let's first write that paint method, right? Right, so this is just like, consider it as something like your main method, right? Something like your main method, but the name is paint. So in your main method, you have string arguments, string args, string array. Here we have graphic object as the argument, right? So graphic object is used to, just like your system out, rather than your system out, you are going to write to whatever you are going to do with this G object, right? G object. Uh, so therefore, we are going to use the G object. So here you don't have this println. Rather, what we have is a drawString. So if you go to the graphic class, you will see that there is a method called drawString. First, there are some parameters, the string you want to draw or print, and the location you want to start. So here we means x coordinate and y coordinate. Here I am saying 50, 25. That means 50 and 25. So write it somewhere here. Hello world in my browser. In my browser. Okay. Actually, when I say in my browser, the applet portion, right? Just like image, you have the applet will be loaded. There, write hello world here. Okay. Right. So just like your main method, consider paint as something like your main method when it comes to applet, right? When it comes to applet, and of course you have to import the graphics package as well, which is in the, so of course it has to be import. It is in the Java AWT package that we will be anyway discussing when we are doing the UI programming. Java.awt.start. I am importing everything. So since I am only using AWT, I am good. I am okay extending from applet. If I am using the string, I have to use the JApplet, right? Right. Now let's compile this. Right. So it has been compiled. That means I have created my applet class. I can't run this. You can see there's no main method. Applets are not meant to be run by your console or UI application. It is to be run by your web browser, right? So now therefore let's create a HTML page, our web page. So let's call it applet demo.html. It can even be a PHP file or whatever. So let's create a HTML file. So I'm not going to have a head also. I'm just going to have the body where I'm going to load the applet. Right. So now let's see how to embed your Java class, applet class that I just compiled to this web page. Okay. For that we have a tag called applet. Right. Tag called applet. It's a standard HTML tag or extension of a standard HTML tag. So let's use that particular tag. Okay. Applet code, you have to give your class name. In my case my applet.java. Remember those are case sensitive, so if you have to make sure that everything is case sensitive. So I'm just going to use, you can give the width and height of your applet window inside your web page, and you can just close your applet tag and close your applet tag. So that's it. Now this particular class will be loaded to the browser and it will be executed as long as your client machine or the browser machine has a machine having the browser has the JDK, not the JDK, even JRE is enough, right? JRE is enough. So that is what it is supposed to do. But unfortunately now, not unfortunately, due to some valid reasons, this is not going to be supported by my browsers. Now, anyway, let's try to run it. I'm just double clicking and opening it in my browser. Right now you can see nothing happened. The reason is browsers are not supporting this by default now, right? So therefore I am going to use the built-in Java tool called Applet Viewer to view this, right? To view this, because browsers does not support applets anymore by default. Okay. You have to get the special version of the browsers. If it is a sort of internal application, still you want to do some applet based applications. Okay, right. Now I am going to use, so it's a console application, Applet Viewer. Applet Viewer. Then you have to give the your web page, right? In my case it is applet demo HTML. To see the applet, right? So something wrong with my code. It says Sun applet panel cannot access member of the my applet with modifiers. Okay, it has to be public class. So I just make it normal class. It says your class must be public. That is one of the error. Let's fix that error first and compile it again. Now let's run it again. Right, now it's fine. I don't know whether you can see it because it's very tiny window, right? I don't know how to zoom this. It looks like, so here you can see very tiny. It is hello world is printed. I must know how to zoom this. So there must be a way to zoom this. and of course there must be way to, because Applet coding is now hardly done, therefore I am also not much using Applets right now. There must be way to increase the font size in my graphic objects, right? So let's see how to do that. How to increase font size in Java graphic drawstring. So you have to set font something like that, right? Right, so let's try to do that so that you can better see it whether it's going to work. Then you have to set that font to the graphic object before calling the drawstring. Let's see whether it's going to increase our font size. Let's compile it again. Still the Applet Viewer is open. So let's compile it again. Run it. Yeah, it's now a little bit bigger. Now I have to increase my applet size also. That we can do here, right? So that we can do here. Let's say 200 and 200 and 150. 200 and 150 with that height. Now our font size has been increased. Now let's compile it again. So likewise, you have to start doing some experimentation. Do Google search. Right. Now still it is not enough. What is that? Okay, so that is the coordinate, not the window size. So I have to, yeah, so I have to increase the, so this is the coordinate starting point, right? So what we have to change is not here, we have to change the HTML and increase the width and height here. Okay, sorry. So let's say this is 250, height is 200. So that is where I am supposed to change. Okay. Right. Now let's. I don't have to recompile because I just changed the HTML. Therefore, I can just open it again the Applet Viewer. Right. Now still the window is not big enough. So let's make it a little bit more bigger. Let's make it 500 by 500. Right. Now you can see. Hopefully you can see. You can even increase the font size now. Let's make it 26. Of course, in that case, let's change the starting point as well. Now I increase the font size to 26. Hopefully that is the font size. We'll see. And then of course I have to pre-compile it. Oh, it's getting back to smaller one. Why is that? Yeah, I think we have to change here. Anyway, let's keep it as it is because I'm not sure what is this parameter, what is this parameter. Okay, so let's keep it for the time being like that. Okay, now it is not coming back. So where did I copy it from? 1 and 70. My font is set. Okay, the setting the font line is missing now. That is the issue because I did some undoing. So let's do that. Set font. So let's make it 30. Right, so now it's, you can see it. Okay, right, so that is how it works. So you have to extend the applet or Applet class, right? Then you have to write the, actually this is your overriding the paint method which is in your applet class, overriding the paint method. So rather than string array, what you have is a graphic object. There you can use the draw string to write something. Of course there are some other things like if you want to paint and other things, but for you just knowing the draw string is good enough. Okay, now let's briefly look at some few more concepts and finish it off. Right, so now you know how to work with applets in basic way and how to use the applet viewer. Now when it comes to life cycle, when you are initializing or when the browser is loading your applet, that means your Java class file, first we say it is going to call a method called init, right? Init. Then we say that your applet is initialized. Then it is going to call the start method. Your browser is going to call the start method. That means your applet is running. So at any time, your Java code can have the stop method to stop your applet being run. And again, it can be started using start method. And finally, the destroy method will be called, especially when you are closing the browser. When you are closing the browser, your browser is going to call the destroy method uh, so that you can do whatever the cleanup things in the destroy method. So what we have used so far is the paint method. So the paint method is basically called, actually this diagram is missing that one, it is going to call this one, paint method, when it is running. So what we have overwritten so far is the paint method, right? We never use the init method, start method, stop method or destroy method. So I am just going to briefly explain uh, how to use these methods as well, uh, because it is mentioned in your syllabus as well. Okay, right, so init method is going to be called once when your applet is initialized or loaded to the browser. Then it is going to call the start, and of course start and stop method we can call it in programmatically as well. When your browser is closed, the browser is going to call the destroy method. Of course you have to write, if you have written those methods or you've overwritten these methods, whatever inside the methods are going to be executed by the browser. When I say browser, the JVM in your client machine. Okay, right, so just to demonstrate that, right, just to demonstrate, we are going to, so I'm just going to copy it from Word document so that I don't have to keep entering lines, because otherwise the lines will be wrapped. Right, I'm just going to demonstrate that these life cycle methods are being called. Right, so I'm just going to let's create another class. uh, let's say my, let's call it my advanced applet Java. And I'm going to copy paste whatever inside my applet class to my advanced applet at first. Then I'm going to uh, just demonstrate these life cycle methods. Okay, life cycle methods. So I should have covered them. Okay, so something like this. Right. So I have overwritten all these methods. I'm just taking string buffer object to write some text. Okay. Right. So then, as usual, I have the paint method. In the paint method, I am printing the whatever the value in the buffer. Right. So now I have init method, start method, stop method, destroy method. Right. So those are the lifecycle methods. Right. Start, init, start, stop, and destroy. Right. And of course, I have the paint method also. Paint method also. So in the start init method, what I am doing is I am creating the string buffer object, and I am adding, or I am adding a text called initializing. So just to check whether it is being called. Then in the start override method, I am just adding that to string buffer. I am adding starting. When stop is called, I am adding stopping. When destroy is called, I am just saying preparing for unloading. Right. So then this add item is something that I have written. There what I am doing is to that buffer I am appending that value. That means your text, because finally I am going to print it. Right. Then at the same time I am writing it to the standard system out println as well. So the system out println is there to see the output in my console, not in the Applet Viewer. Right. Not in the Applet Viewer. It is going to see the output in the console. Right. So what happens is, every time this event happens, I am modifying the buffer, my buffer object, and my paint method is going to print the buffer, and it is going to print the buffer. That is my stream buffer, right? Stream buffer. And while it is being printed to the string buffer, whenever I am calling the add item, it is going to be printed to the system out println as well. Okay, and I am calling the repaint method. So the repaint method means I am calling the paint method. So that is something I forgot to mention. So the paint method is only called once by default, but at any time you can call the repaint method. Whenever you call the repaint method, the JVM is going to call the paint method. Right. So that is again you have to remember. So now you can see that every time this active action occur, or this life cycle action occurs, I am adding to the buffer and I am calling the repaint. That means I am calling the paint method. So that means whenever that action occur, you are going to see that text in the Applet Viewer. Not only in the Applet Viewer, you are going to see it in the your console as well. Right. Right. Now let's compile and run it. So let's call it my advanced applet. Right. For that, I am going to create another HTML file as well. Advanced applet demo. So there I am going to connect this one. Okay, advanced applet class. Now let's compile everything again, so that my advanced applet is also going to be compiled. Okay, now let's run the using the Applet Viewer advanced applet demo HTML. Okay, Okay, so maybe file name is wrong. Okay, now you can see initializing, you can see here, starting you can see here, right? Initializing, of course, let's increase the font size. I forgot to increase the font size, you can see it. So I forget to increase the font size. Right, so I'm creating the font size 30 and setting it to the G so that you can see it bigger. Right, let's compile it again and run it. Okay, so it should have been another one. Sorry. Right. Now you can see that it is saying initializing and starting. Here also you can see initializing and starting. That means when I start this applet, load this applet, now you can see this lifecycle method called initializing or initial init is called, right? And also start has been called, right? Start has been called because in the init method, I wrote initializing. In the start method, I wrote starting. Now you can see still the stop method has not been called. Destroy has not been called. Right? Stop and destroy has not been called. Only the init and start has been called. Of course, I can call the stop method, right, at any time and again start it. Right? Again start it. I am not going to do that right now. But let's see whether destroy method is getting called when we are closing the applet. Of course, you can't see it because the moment I close this, you are not going to see this what is here. That is why I'm adding to the print system out as well, because anyway it will be printed, but after instantaneously this is going to vanish. Therefore, you are not going to see it here. But let's look at whether you are going you can see it in the console, whether those are also getting called. Now I'm going to close this. Now you can see stopping, that means stop method has been created, call and unloading. Unloading has been coded in the uh, destroy method, right? Preparing for unloading. So that is destroy method. So now you can see that lifecycle method has been called. So we are not calling, your JVM is going to call all those methods. So when the applet is loaded, init is going to be called, right? Whenever we call the repaint, right? Whenever we call the repaint, the paint is going to be called, right? So that is why you saw initializing and starting, right? And when you close your browser, it's going to call the stop and destroy. Of course, stop and start you can call it programmatically as well. That we didn't demonstrate you. Okay. So it's very important to know those life cycle methods. Init only once call, start and stop anytime you can call. Destroy only once call when you are closing the browser window, the tab, right? Paint you can call at any times. Only once it will anyway call. Anytime if you want to call, you have to call the repaint method from your other methods. Whenever you call the repaint method, it is going to paint. Paint means it's going to refresh the output or the your browser, your applet viewer. Okay, right. So we are done with that. So we are not going to discuss anything else. So I just gave you the basic of how the applet works, right? And just maybe just one more thing I want to explain. If you want to get some parameters from your web page or the HTML or from JavaScript or whatever, they have method called get parameter. From the get parameter, you can read the value from your HTML text and use it in your applet as well, right? For example, if you have, so this is just the applet. If you have parameter like this, right? then in your init method you can get that parameter value and use it in your applet. So I will just demonstrate that as well. Yeah, then that's the end of it. Right, so let's create a class called new text document applet param demo java. So I'm just going to copy paste this because otherwise I'm wasting my time. So let's call it applet param demo. So you can see in the main method, in the init method, there's a method called get parameter. So you have to give the parameter name and then you get the parameter value. So we are just setting it to the instance variable so that in the paint method we are printing that, right? So the display string is the instance variable we set in the init method, which you are using in the paint method, right? Paint method. Now let's see. Of course, in drawstring we have to make it a little bit bigger. So therefore, I'm going to set the font again. To make it a little bit bigger for you to see. Right, that's it. Right, now let's compile our Java classes again. I'm just compiling everything. Okay, font. Okay, let's import everything. Okay, because then the font must be in the AWT. That is why I'm always importing everything, then otherwise I have to import each and every again, right? So now I have compiled that one. Let's create another HTML page as well, so that you have the 3 classes, 3 applets and 3 HTML to demonstrate that. Right, now class name is applet param demo. So let's change it there. Right, now I'm going to set the parameters, 2 parameters, one parameter that we read from the class. So let's call it display name because that is how you are getting it here, display name. So therefore I'm just set it to you can have any number of parameters like this. All those parameters are available to the applet. Okay, now let's look at this in the applet viewer. Right, so you can't see it much because there's something, window is overlapping. So it says actually hello John Smith, right? Hello John Smith, that is the parameter I'm sending here. So John Smith, right? So we are just saying hello John Smith, hello together with hello, right? So that is what you are getting. Okay, right? So we discussed few things. So few things that you want to remember is, first, if you are creating applet, applet means something to be executed or run by your browser, not by the console or the applet viewer class application. If you are creating applet, you have to extend either applet class or applet class, right? Then there's a method called paint which will be automatically called or you can always call it by calling the repaint method, right? Then there are some life cycle methods like init, start, stop, and destroy. Init, start, stop, and destroy. And if you want to send some parameters to the applet, you can send those parameters from your HTML tag itself, right? Using the param tag inside the applet tag. Those things you can get it through get parameter method. That's it. You are supposed to know at this level, because anyway applets are going to be used less and less in the future and maybe die down. So yeah, so we are done with applets. So we discussed two topics today. We discussed the file handling, we discussed the applet handling. So if you have any questions, you can ask. Otherwise, we are going to just stop it.